The isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if I'm looking at a picture of a triangle, such as this one, and I know that this leg is congruent to this leg, then that tells me that those angles that are across from it, the angles they are pointing at, which would be this one and this one, are also congruent. So if I know that this triangle, it says it's an isosceles triangle, that means this side and this side are the same. So that tells me again that this angle and this angle are the same. And that's always going to be true. So if it's isosceles, it tells me to solve for x and find the lengths of AB, BC, and AC. If it's isosceles, isosceles, remember, means two equal sides. Means that 8x minus 24 is equal to 6x plus 20. So I can solve for x, which means I want x's on one side, my number's on the other. So I'm going to minus 6x from both sides. And I get 2x minus 24 equals 20. Then I can add 24 to both sides. So I get that 2x equals 44. For my final step, I divide both sides by 2, and I get x equals 22. In order to find my missing sides, I actually have to replace my x's with 22. So that means I need to replace this x with 22. I need to replace this x with 22. And I need to replace this x with 22. And then I just have to do some math. So 8 times 22 minus 24, I'd put it in the calculator, and I get 152. And then I do the same thing for 6 times 22 plus 20. I just type it in the calculator, and it's going to give me 152. Which makes sense because these two sides are supposed to have the same measure. And then I do my last one, 5 times 22 minus 1. And I get 109. So my base in this case, my bottom leg, is 109. So the inverse of this isosceles triangle theorem says if two angles of a triangle are congruent, then the sides opposite those triangles are congruent. And that is a true statement. So that means if you have a triangle and you know this angle is 50 and this angle is 50, well then what that tells you is that this side must be congruent to this side because they have the same angle measures. There are two corollaries. Corollaries are things that we take from theorems that must also be true. And the first corollary is that if all three sides are congruent, all three angles are congruent. So the original theorem said that if two sides are congruent, two angles are congruent. The corollary says that if three sides are congruent, all three angles are congruent. That's our first one. That's where we get equilateral and equiangular triangles from. Our second corollary is that in an equilateral triangle, that means all three sides are equal. All angles are 60 degrees. So that's our second corollary, is that in an equilateral triangle, all angles are 60 degrees. So we have this hexagon here that's been broken into different pieces. It says to name 3 straight angles. Straight angles are angles that make straight lines. They are straight lines. So for example, angle FGC is a straight angle. angle EGB, and lastly, angle AGD. Those are our only 3 straight angles that we have. Then the next question says, true or false, that angle ADC, that's the angle made by connecting A to D to C, so this angle, is congruent to angle GEF. That would be made by connecting G to E to F. Is congruent to this one. So you have to decide, are these 2 angles the same? Well, if you think about this as a hexagon, and all of these triangles are congruent, that means that this leg is congruent to this leg, and it's congruent to this leg and this leg. So the angles opposite of those are all going to be the same. So this angle is the same as this angle, is the same as this angle, is the same as this one. So yes, they are congruent. It's true. And the last question says, what is the measure of angle AGE? Well, AGE would be made by connecting A to G to E. So it'd be this part right here. Well, if you think about a circle, we haven't really talked about this yet, but in a circle, there is 360 degrees. And we could imagine that there's really a circle right here, with this point being the center, and that means that circle is split into 6 pieces. So since there's a whole circle is 360 degrees, I can do 360 divided by 6, and I'm going to get 60 degrees. So that tells me that each of these pieces is 60 degrees. And if they're each 60 and I want to know how big this part is, all I have to do is add 60 and 60 and I get 120. So page 14 says that the longest side of a triangle is always opposite the angle with the blank measure. Well, let's think about if we had a triangle. So I'm going to draw them with one really long side. So clearly this is the side that's the longest, and it's across from this angle right here. Well, if you look at that angle compared to the other two, to these two that I'm drawing in pink, that blue one is really big. And so the longest side of a triangle is always the opposite the angle with the biggest measure. Well, then the opposite of that is true, that the shortest side of a triangle is always opposite the angle with the smallest measure. So just looking at a picture, if I had a triangle with this little bitty side over here, this angle that's opposite from it is this angle, and that angle is really small compared to these other two. Question 1 says, what is the measure of A in degrees? Well, what I want you to notice is that this side is 20, this side is 20, and this side is 20. If all sides are equal, that means it is an equilateral triangle. That means all angles equal 60 degrees. And that is true for every equilateral triangle, every single one of them. If it's equilateral, all angles are 60 degrees. Question 3 says, what is the measure of angle A in degrees? So I need to find this angle. Well, it doesn't tell me a lot about A, but I do know that this side and this side are equal. So that means that the angles across from them, which would be these two in pink, are going to be equal. One of them was 42, the other one must be then 42. And I know that in total, the degrees of a triangle add up to 180. So that means that 42 plus A has to equal 180. 42 plus 42 is 84. I'm going to solve for A, which means I'm going to subtract 84 from both sides. And I get that A equals 96. Number 5 says, what is the length of AC? Well, AC is this part, because this is 55 and this is 55. What I know is that AC and BC are congruent. So So that means that 2x plus 4 equals 5x plus 1. I'm solving for x, which means I want x's on one side, my number's on the other. So I'm going to minus 5x from both sides. I get that negative 3x plus 4 equals 1. Then I'm going to subtract 4 from both sides, so I get negative 3x equals negative 3. Then I'm going to divide both sides by negative 3, and I get that x equals positive 1. Remember, the question didn't ask me, though, what's x? The question asked me, how long is AC? Well, I know AC is 2x plus 4, but I just found out that x is really 1, so that means it's 2 times 1 plus 4. And 2 times 1 is 2, plus 4 is 6. So AC would be 6. Number 7 says, which angle of DEF has the largest measure? Remember, the largest measure is across from or opposite the largest side. So I've got to figure out which side is the biggest. Well, 12 is the biggest, and the side that's across from that, or the angle that's across from that, would be angle D. So that one's going to have the largest measure. Number 9 says, which angle of ABC has the smallest measure? It's going to be opposite the smallest side. So my smallest side here is 37. The angle opposite of that is angle B.